What we're going to look at right now is a review of solving quadratic equations for the fall final exam. So we're going to start by solving by factoring. So number one, we have a squared equals -2 plus 3a. In order to solve by factoring, we need to start with the equation equal to 0. So I'm going to subtract 3a to the left side and add 2 so that I get a squared minus 3a plus 2 equals 0. And then I'm going to need to factor. So I set out my two parentheses. There is no greatest common factor, so I'll look at the first terms have to be a's, the last terms have to be 1 and 2. They need to be the same sign, and both are negative. So after I have it factored and equal to 0, I will take each parenthesis and set them equal to 0. So the solutions would be a equals 1 and a equals 2. Number 2 is 3x squared equals 15x. So again, I'm going to subtract 15x over. So I get 3x squared minus 15x equals 0. I see that there is a greatest common factor. The greatest common factor between these terms is going to be 3x. So I'll take 3x out front, which leaves me x minus 5 inside the parentheses. And there's no more factoring to be done. I have x minus 5 equals 0, so x equals 5. And since there's an x in my greatest common factor, I have 3x equals 0. So when I divide both sides by 3, I get x equals 0. Number 3 is 7p squared equals 224 minus 28p. I think you get the gist that I'm going to be moving all of my terms to one side. So I have 7p squared plus 28p minus 224 equals 0. Okay, let's check and see if there's a common factor. Maybe 7 might come out. Let's see if 224 is divisible by 7. 7 goes into 22 3 times. Subtract the 21. I get 1, 14. Yes. So 7 will come out of all of those terms. So let's factor out the greatest common factor of 7. So I have 7 times p squared plus 4p minus 32 equals 0. So I have 7, set up my two sets of parentheses, and then p times p has to go at the beginning. Let's see, I need to multiply to give me 32, so it could be 1 and 32, 2 and 16, 4 and 8, and I need the inside and outside to equal 4, so it's going to be plus 8 and minus 4. So now I have p minus 4 equals 0, or p plus 8 equals 0. I do not use that 7. I'm going to ignore the 7 out front since it doesn't have a variable. So I'm going to get two solutions, p equals 4 and p equals -8. We have one more to solve by factoring. Number 4, 7x squared minus 63x equals -140. So I'll add that 140 over. That should be a 63. Okay. So 7x squared minus 63x plus 140 equals 0. Looks like I have a common factor of 7. So 7 times x squared minus 9x plus 20 equals 0. So 7 times, first terms will be x and x. Last terms need to multiply to 20, so 1 and 20, 2 and 10, 4 and 5. And I need to add to get -9, so it'll be -4 and -5, which gives me x minus 4 equals 0, so x equals 4. And x minus 5 equals 0, so x equals 5. And remember, when your greatest common factor doesn't have a variable, we just ignore that. So this one will have 2 solutions. The next method we're going to use to solve quadratic equations is the square root method. And the square root method works when there's a squared thing but no x term. So no other variable terms. So let's see an example. Number 5, we have negative 7n squared equals negative 56. Number 6, negative 3a squared equals negative 87. So in both of these cases, I have a squared term. In this case, it's n squared, but I need to divide by the negative 7 so that I isolate the squared thing. So that gives me n squared equals 56 divided by 7 is 8. And after the squared thing is isolated, we take the square root of both sides. So it gives me n equals, and I have to remember to use plus or minus. So that's going to be plus or minus, and then 8 breaks down into 2 times 4, which is 2 times 2 times 2. So a pair of 2's comes out, and a 2 stays in. So 2 square roots of 2. Negative 3a squared equals negative 87. Almost the same problem. Let's divide both sides by negative 3. So a squared equals 29. Take the square root of both sides, and we get a equals plus or minus the square root of 29, because that won't simplify. Number 7, we have negative 8x squared equals negative 464. And number 8, negative 8v squared equals negative 416. Okay, so we will divide both sides by negative 8, which gives us x squared equals 8 goes into 46 5 times, and then 64 left, so 58. And then take the square root of both sides. So x equals plus or minus the square root of 58. And we should check to see if 58 breaks down. It would be 2 times 29. 29 is prime, so that's as far as that breaks. Let's see on number 8. We'll divide both sides by negative 8. So we get v squared equals 416 divided by 8. 8 goes into 41 5 times, and then 2. So v squared would be 52. Take the square root of both sides, and we get v equals, we have to remember our plus or minus, square root of 52. 52 breaks into 2 times 26. 26 would be 2 times 13. So this pair of 2's comes out, the 13 stays in. So v is going to equal plus or minus 2 square roots of 13. The next method that we're going to use is completing the square. So to solve by completing the square, what we want to do is get all the variable terms on one side and the constant term on the other. So we will subtract the 50 over. So we have b squared plus 18b equals negative 56. And then if we have a coefficient in front of the x squared or the b squared term, we'll need to divide all the terms by the coefficient of the squared term. I'll just put x squared, but it could be any letter. Then we are going to find half of b, so b divided by 2, and we square that, And what we do with that is add it to both sides. So I will find 18 divided by 2 squared. Well, 18 divided by 2 is 9. 9 squared is 81. So I'm going to add 81 to both sides. And then I'm going to use this b over 2 to factor. So I'll factor the left side into x, and then whatever b over 2 is, if it's plus, it'll be positive. If it's positive, it'll be plus b over 2. If it's negative, it'll be minus b over 2. So x plus or minus b over 2 squared equals whatever your number was. So on this problem, this is going to factor into, since 18 halves, which is 9, is positive, the left side will factor into b plus 9 squared, and that's going to equal whatever negative 56 plus 81 is. Let's see, 56, 66, 76 is 25, so positive 25. And then we will solve by the square root method. So at this point, I will take the square root of both sides. And the square root of b plus 9 squared is b plus 9. So I get b plus 9 equals, when I take the square root of 25, it is plus or minus 5. And then to solve for b, I will subtract 9 from both sides. That negative 9 is going to go in front of the plus or minus 5. So b is going to equal negative 9 plus or minus 5. Now, since 9 and 5 are like terms, I can actually do both of those problems. So I will be working b equals negative 9 plus 5 and b equals negative 9 minus 5. That's going to give me my two solutions of b equals negative 4 and b equals negative 14. Let's look at another completing the square. N squared minus 18n minus 48 equals 6. This is number 10. So again, we need to get the variable terms on one side and the constant terms on the other. So I'll be adding 48. So I have n squared minus 18n equals 6 plus 48 is 54. Then I would need to divide all terms by the coefficient of the n squared, which is just 1, so that step is done. Then I'll find b divided by 2 squared. So this time it's negative 18 divided by 2. Well, negative 18 divided by 2 is negative 9. Negative 9 squared is 81. So I'm adding 81 to both sides. So now I have n squared minus 18n plus 81 equals 54 plus 81. So my next step is to factor the left side. So this is going to factor into n, and since it was negative 9, it'll be n minus 9 squared equals, what is 54 plus 81? 135. And then I'll take the square root of both sides. So n minus 9 equals plus or minus the square root of 135. Now we'll need to see if 135 can break down. Let's see, it would be 5 times 27, which is 5 times 3 times 9, or 5 times 3 times 3 times 3. So I have a pair of 3's that come out, and 5 times 3 stay in, so n minus 9 equals plus or minus 3 square roots of 15. I need to then add my 9 over to the other side. It's going to go in front of the plus or minus. So we get n equals 9 plus or minus 3 square roots of 15. And since those are not like terms, I cannot combine anything, so that will be my final answer.